Hello, folks. So in this video, I want to talk about how I would go about solving these more interesting slash spicier trig equations. So I thought it would be really helpful for us to have just kind of a written recipe, so we can kind of approach them with the same procedure, or at least more or less the same procedure every single time. I want to emphasize that if you keep doing these practice problems, you would eventually probably get to a system of some kind, right? So that's always how you should be studying or practicing. Is that obviously you always want to be able to think about things in different ways. So when you're first learning, you're exploring and see, can I do it this way or that way? But eventually, you do want to settle on a method that is kind of tried and true, excuse me, and somewhat efficient. So in this video specifically, I'll talk about the strategy without an actual example, just to get all the points out there. And then in the next couple videos, we'll do an example kind of showcasing different pieces of this process. Okay, so step one is to rewrite the equation. So we're assuming that the equation is somewhat more interesting than just a simple something along the lines of, say, sine of theta is equal to pi, or sorry, sine of theta is equal to, I don't know, root 3 over 2. That'd be a boring example. So not really the purpose of this kind of whole video. But I might have something more along the lines of this. Sine squared of theta plus 2 sine of theta is equal to, let's say, plus 7 is equal to 0, suppose. So often we want to rewrite the equation in one of two main ways. Actually, I'm going to change this to, let's say, cosine, just to get the point across. So there are two ways that I kind of categorize rewriting these equations. One way is to make sure that all your trig functions are the same. So that would mean all sines or all cosines or all tangents or whatever. Right, so that's going to be all sine or all cosine, etc. In addition to that, you would also like to have all your arguments be the same, because if they're not, I can't usually use a lot of my identities. So again, the argument is just the thing that you're inputting into the function. So I don't want to have a mixture of, let's say, cosine of 2 thetas and cosine of thetas. I would prefer to have all the same argument. Okay. So in this example, and the way you're going to do that is by using the miscellaneous identities that you've come across in your training. So for example, here in this red one that I've made, we could replace cosine squared with 1 minus sine squared plus 2 sine of theta plus 7 is equal to 0. I've then achieved the goal that I wanted, which is that all of these trig functions are actually the same. They're all sine. Okay, that's one way to do it. And then we talked about, there are other strategies about how you actually then solve it once you got here. But that's the overview is to rewrite it in some way that makes it more bearable. The other way is to make it into some kind of factored form. Let's pull, oopsies. How do I get back here? Sorry, we're using a new version of OneNote here, and I'm still kind of figuring things out. I just want to change the color of my pen. Oh, over here. Okay. Go away. All right, so our factored form. All right, cool, we're in purple now. Our factored form, so what I mean by that is if there's a way to write it in some kind of factored form, it's okay if you have two different trig functions or multiple different trig functions, because it's going to boil down to two separate equations anyway. So an example of that, let's kind of zoom down here, would be if I had something that could boil down to, let's say, cosine of theta minus 1 times, I don't know, cosecant of theta plus 2 is equal to 0. Because once I've done this, I can use my zero product property and just say, oh, okay, cosine of theta has to be equal to positive 1, cosecant of theta is equal to -2. And again, these are now relatively simple equations that I could solve individually. Okay, remember that at the end of the day, no matter how you rewrite it, your goal is to get it into some form of this, which is what these are. Okay, so you're trying to get to f of something, and when I say f of, that f of something, f of x or f of theta, is going to be some trig function, so sine of something or cosine of something, is equal to some number. I called it big C here. Again, once you've got it down to there, it becomes relatively easy to solve. At worst, it would be a value that is not known, in which case you'll use a calculator anyway. Okay, so I keep saying that once it gets down to this point, it becomes relatively simple. So how do I actually do that? Okay, so let's clean this up. All right, let's talk about this. Maybe we'll try blue. All right, so let's deal with number 2 here. Okay, so once you've got it down to the simple stuff, how do you actually solve it? So I think this case actually calls for an example. So let's pretend that I've boiled my equation down to, let's say, cosine of, I'm going to say 2 theta plus pi over 3 is equal to 1/2. Okay, so let's say I boiled my equation down to this. Okay, so once I've gotten down to this, here's my step A. So step A is figure out what the stuff, quote unquote stuff, has to be. So in this example, the stuff is this entire thing that you're taking the cosine of. This entire quantity, 2 theta plus pi over 3. So I'm kind of zooming out, blurring my vision a little bit, and just imagining this is just some angle, which, well, not imagining, it is some angle. This is just some angle with a cosine value of 1/2. So let's think, okay, well, if the cosine value is 1/2, that means I'm 1/2 over in the x direction. And so the first one that jumps out to mind is this angle right here. That would be pi over 3, right? 60 degrees. And so I could go pi over 3, but of course, remember, I could go a full revolution around and go another 2 pi after that. I could go around again and another 2 pi after that, and so on and so forth. So if this angle, when I take the cosine of it, rather, the cosine of that angle is equal to 1/2, that stuff is going to be equal to pi over 3 or any revolution afterward. That, again, is not the only angle for which this will work, because let's change colors here. If I go downward at negative pi over 3, I'll get the exact same cosine value. And so once again, I would have negative pi over 3, and again, any revolution afterward. So plus 2 pi n. Okay, so that's what this angle has to be. And when I say this angle, I'm pointing at this yellow highlighted entire argument of the cosine function in this problem. Okay, so that would mean, in this case, 2 theta plus pi over 3 is equal to that, or 2 theta plus pi over 3 is equal to this, the red thing. Okay, so that's all part A. So let's maybe label that here, part A. Fantastic. Now, again, solving the equation means find the value of theta, not 2 theta plus pi over 3. So now we'll just isolate that theta. Okay, so that's going to look like this. So it's going to be the exact same process in both of them, because the way you're solving theta is exactly the same. So we're going to subtract pi over 3 and then divide by 2. So that's going to I'm going to fast forward this step a little bit, but this will be theta is equal to 0, and then divided by 2 is still 0, plus 1 pi n. Or in red, I'm going to get theta is equal to negative 2 pi over 3, negative 2 pi over 3, plus 1 pi n. Sound good? I'm kind of more talking to myself here, just double checking. Because again, I made this example up on the fly. Okay, so that's step B. So now it turns out that this angle, the angle that we're actually looking for, theta, is any angle that is a multiple of pi. It comes from this, or that is any angle that is negative 2 pi over 3 and then multiple of pi afterward. Okay. Now we want to make sure that we only give solutions that are in the desired domain. So I didn't actually specify one in this example, but let's actually put an example on here, or restrict the domain in this example. Let's pretend I want theta to be from 0 to 2 pi. Okay, so if that's the case, then I'm really just plugging in n values. So a way that might be helpful would be to make a table. So I'll plug in n, I'll plug in, or sorry, not plug in, but make a header right here. And then in red, we have negative 2 pi over 3 plus 1 pi n. And we'll just start off at 0. Again, starting off at 0 is probably the most logical thing to do. Although you technically could start off at a negative number, because n could be negative. You could go backwards. So I go 0, 1, 2, and 3. And let's just see what happens. So when I plug in these values, I'll get, well, 0 times pi is 0. So 0, 1 pi, 2 pi, and 3 pi. And red is going to be a little bit harder, but negative pi over 3. So the way that I think makes this a lot easier is if I just convert this to pi thirds, so I can add my common denominator, or I can get my common denominator, or just have it at the ready. So this is 3 pi over 3, n. Okay, so negative 2 plus 3 would be 1 pi over 3. Plus 3 pi over 3 again would be 4 pi over 3. Plus 3 pi over 3 again would be 7 pi. Oops. 7 pi over 3. Okie doke. So at this point, we just need to make sure ask ourselves, okay, which of these angles actually fits in the space that we want? That space being, again, from 0 to 2 pi. Well, if you just look at it here, we can actually really see these. This fits, this doesn't, this does. Let's see, we say, strictly less than 2 pi, so neither of these will work. This one will work, and this one will work, but this is too far. Okay, so as far as this equation is concerned, these are our 4 solutions in this example. The last step would be to check for extraneous solutions. That's going to be step D. But because I didn't start with an equation at the very beginning, this example will not have that. So I'm going to save that for the next video. But again, hopefully this helps you kind of have a little checklist of things to do. So again, starting from the very, very beginning, step 1, you're almost always going to have to rewrite your trig equation if the problem is like interesting. So you're going to have to rewrite it in some way using your identities that you know. So again, common identities to use, your Pythagorean identities. Whenever you see a cosine squared or a sine squared, or really any trig function squared, you can think about this. Converting things from tangent or cosecant or secant into just sines and cosines could also help you. As well as your double angle or half angle formulas. Keep those in mind as well. Or go about and try to factor the entire thing. If you can get it to be factored on one side, something times something is equal to 0, then you could just use your zero product property, and that's super nice too. Again, all the purpose of this rewriting is to get it into this basic form that looks something like this. Some trig function of something, like just a single trig function, equals some number. That's what you're looking for. Because once you've got that, then you can just figure out this process. And this process, again, is always the same. Step 2 is always the same, or at least the same steps, right? So figure out what the inside angle has to be, depending on the problem. If it's a textbook problem, this will probably be a known angle or a known trig value, in which case you'll just have to remember your unit circle. If it's not one of those, you could just use your calculator. And then solve that, figure out what that angle has to be. then isolate your theta or x, depending whatever variable the question is using. And then just make sure you're only giving in us the solutions, values of n, that are actually fit in the domain that the problem is asking you for. And then check for solutions that are either extraneous, or go back and see if you ever possibly lost a solution from one of your irreversible steps. So again, in the next couple of videos, we'll do some more examples of these, but hopefully this helped kind of lay some ground rules, if you will. Thanks for watching.